Hey guys, welcome back to Algebra 2. This is lesson 86. There's stuffing a lot into one lesson today, so let's get into it. They say to graph x is less than 3, but the domain is positive integers. ¿Qué significa todo eso? We need to graph on a number line all the possible solutions of x when x is less than 3, but you can only have positive integers as your answer, okay? So those are the boundaries. It has to be less than 3, not equal to, but just less than 3, and it can only be positive integers. Well, look, if it can't include 3, we're not coloring it. The only two positive integers less than 3 that are positive are 2 and 1. It doesn't make any sense to do that because it's only positive integers. It's nothing in between. Okay, it's only integers, no fractions, nothing like that. So you're going to start right here. It includes that one, and it includes that one. Nada más, nada menos, okay? And if you're looking at me like, well, I don't understand that, Miss good. Just process it, okay? You guys process it. You have to find the solutions that are less than 3, but they can only be positive and they can only be integers. Positive, the only two positive numbers less than 3 are 2 and 1 because they're integers. It can't be 2.5, can't be 1.1, nothing like that. Okay, can't be 0 because that's not positive. So there you go, that's all you got. Now in this one, it has to be greater than -3, and beautiful thing is it can be all real numbers. I love it when it says all real numbers because literally you don't have to think about anything. You just put -3 on your number line. You don't color it, but you have to put it there because even 3.1 is included because it's a real number. -3.1, pardon. I mean, no. Anyway, whatever. The next decimal above -3 is included, so you have to put it like that. So everything else is included, just not -3, but everything else after that is included. Decimals, fractions, doesn't matter because it's a real number. Okay, so you put it like that. No integers involved. Okay, example 3 then starts to twist things a little bit. What if you see it like this? X is not less than or equal to -4. Well, guys, if it's not less than or equal to -4, it has to be greater than -4. That's the opposite, okay? You flip it around and take off that equal sign because if it's not equal here, it's not going to be equal when you flip it either. So you flip it and take off the equal sign. So if it's not less than or equal to, it has to be greater than -4. And it can only include negative integers. Well, there's not many negative integers above -4. So you have -4 right here. What are the negative integers above -4? Just these. This is not included, so it's just these. And there's your answer. Look at example 4. We're trying to get deeper and deeper into all the possibilities that you could see. Woohoo! It can be all real numbers, so that's going to make our graph easy, but it's not greater than 2, so it's -x plus 4 is less than or equal to 2. Okay, so that's the complete opposite of it. Then what happens though? You have to solve for x. So you have your -4 over here, that's -2. X is less than or equal to -2. But then you have to take off that negative sign, and guys, when you do that, you're basically dividing by a -1. And if you divide by a negative number over here, you have to flip that sign again. So it's going to be x is greater than or equal to 2. Okay? X is greater than or equal to 2, and then you can graph it. So be careful, because it's all real numbers. Be careful what happens. It flips here with the equal sign because that's the complete opposite. If it wasn't equal here, it could be equal here on the opposite. But then when you go to divide by not add or subtract a negative number, divide a negative number, you have to flip the sign again. Okay, but this time you keep that because it's not the complete opposite, you're just flipping the sign. Okay, so that's your graph right there. Okay, last one for graphing, then we're going to go into example 6, which is just a completely different topic. Okay, domain is real, no, I read that completely wrong. Wishful thinking, I think. Negative integers. Okay, now let's do this one. This is gonna flip and lose the lose the equal thing because it's the complete opposite over here. Then we solve for x, that's positive, so it's gonna be negative x and 2. So now it's gonna be positive x, negative 2, and flip the sign, right? So now we're saying all the negative integers that are greater than negative 2. Well, guys, there's only one negative integer that is greater than negative 2, so that's your graph. I see it like that. Okay? Now we're going into a section called irrational roots. Honestly, it doesn't really matter what they call it. We solved this just like we solved the one the other day. It's just you're going to come out with a weird answer, that's all. We know that this is the, now we know that this is the graph of a circle, right? Okay. When you have an x squared and a y squared, that means you're going to have 2 answers for x and 2 answers for y. I'm not going to lie to you. These are interesting, and you're going to have to use the quadratic formula. So anyway, let's figure this thing out. What I'm going to do first, I'm going to substitute here. So, get ready to substitute here. So it's going to be x plus 1, right? And I'm going to substitute into there. So that's x squared again, plus 2x plus 1 equals 9, because this is going to be your y squared, right? So that's 2x squared plus 2x plus 1 equals 9. Okay, well, we could use the quadratic formula, but maybe we want to try completing the square first. Let's try completing the square first, okay? So the very first thing I'm going to do is move this 9 over here. So 1 minus 9 is negative 8, right? And divide by 2, divide by 2, divide by 2. So that's going to be x squared plus x minus 4 equals 0. So you move the negative 4 over here to make it positive 4. Okay? I'm scaring myself already because I'm not doing the way the book did it, so we're going to see if this comes out, but you should be able to complete the square, right? So we're going to see if you can. Okay. So, okay. So you're going to have a 1 here, you divide by 2, right? 1 divided by 2 is 1/2, and then you square it. So 1/2 squared is 1/4. And you add the same thing over here, right? Then you do your parentheses. It's 1/2 again squared equals 4 plus 1/4, well, that's 17/4. Right? Because that's 4 is 16/4. And then plus 1/4. Then you take a square root and take the square root, right? I'm going to start writing it over here because to make it bigger. You have x plus 1/2 equals square root 17 plus or minus square root 17 over 2 because the square root of 4 is 2. And then you move the 1/2 over. So you have x equals negative 1/2 plus or minus square root 17 over 2. Okay? The problem with that is you're like, oh, okay, that's great. I have my 2 x's, right? I have my negative 1/2 plus square root 17 over 2 and negative 1/2 minus square root 17 over 2. The biggest problem with all of that is what do you have to do to find y? What do you have to do to find y? You can either substitute this crazy looking answer into one of these things, right? Or you can solve for x here and then do the same process down here. I'm going to show you that it's not as crazy as you really think that it is, okay? I'm going to write out my answers like this. -1 plus square root of 17 over 2 and -1 minus square root of 17 over 2. Right? Those are my two x's. I already know that I lost some of you guys, and it's just because you don't want to process. So process. Or stop the video and try the example after I'm done, again, to see if you get the same answer, right? So look, I'm going to take this one right here and substitute it in for x. So I'm going to have y minus -1 plus square root of 17 over 2 equals 1. Okay, let's get rid of all this. You don't need that anymore. Okay, so that's going to be y plus 1 minus square root of 17 over 2 equals 1. And then we have to subtract it over here. So it's again 1 minus square root of 17 over 2. So that's going to be 2 over 2 minus 1/2 plus square root of 17 over 2. Right? So you go 2 minus 1 is 1 over 2 plus square root of 17 over 2. And that's your first y. So with this x right here, my y is 1 plus square root of 17 over 2. Okay, now let's do it for this one. Right? Fun times. I'm just checking my answers and they're good so far. Okay, let's do it for this one right here. So now we have y minus, again, -1, -17 over 2 equals 1, right? Now I'm going to make it easier on myself this time, and I'm just going to move all this over here as a plus, because that's what's going to happen if you go back and forth with all that. So y equals 1 plus -1 minus square root of 17 over 2. So let's break it up. 2 over 2 minus 1 over 2 minus square root of 17 over 2. So that's going to be 2 minus 1 is 1 square root 2. 1 over 2, pardon, minus 17 square root 2. Okay? It is tedious, but it's not hard. It is tedious, okay? And we're going to have another practice on it on the practice. So go ahead and try your practice, and then I'll come back and show you how we got them. Okay, nobody likes letter B, I know that, but look at letter A, it's easy. Negative x is not less than or equal to 4, so that must mean that negative x is greater than 4. But then you have to get that negative x off of there, so it's going to be x is less than negative 4. It can only be integers. Well, don't be like me and do 4, 3, 2, 1, because that's not how negative numbers work. I did that first and then realized what I was doing. Negative 4, negative 5, negative 6, negative 7, I'll say eternity for the negative integers, because there's no positive integer that's less than negative 4. So you have to color in 5, 6, and 7. Okay, here we go with this one. So we're going to move this over here to be equal. Y equals x plus 1, and I plug it into this. X squared, and then we square this, so it'll be x squared plus 2x plus 1 equals 11. I move my 11 over here to make it negative 10, and I divide everything by 2 to get the 2 off of this x squared. That leaves you with x squared plus x minus 5, but I move the 5 over to make it positive to complete my square. This is an invisible 1. 1 divided by 2 is 1/2. Squared is 1/4. I have to add that over here and add it over here. So then I have x plus 1/2 squared equals equals 21 over 4, because 5 is 20 over 4 plus 1 is 21 over 4. Take the square root of both of them, and I have x, I move it over here, x plus 1/2 equals square root of 21 over 2. Plus or minus, right? So I make this, I move this over here and make it negative 1/2, right? So it's negative 1 plus square root of 21 over 2, and negative 1 minus square root of 21 over 2. I substitute both of these into y. What you end up getting is, when you move this over here, it's going to be 1 minus 1 plus square root 21 over 2. So that's 1 minus 1 is 0. So you're left with square root 21 over 2. Then the second one, this one, is y minus that. So you move it over and it's 1 plus negative 1 minus square root 21 over 2. Right? Can you see that a little bit? And then you have 1 minus 1 is still 0. So it's negative 21 over 2. Whew, and there's your practice. Okay, if you have any questions, just let me know. Bye.